Alright, here is the video guide for lesson 3.2.4, and we're going to look for another condition of triangle similarity. So the ones we're familiar with again are angle-angle similarity and side-angle-side. Is there another one we can discover here today? And so we're going to start off by looking at the first problem, a little long here, but they're saying we are using the condition, we're going to try to test out this condition where you only need two pairs of corresponding parts. Let's just calculate the ratio for the two pairs of corresponding parts to determine the triangles are similar. And so what they're going to do here is that enough information? That's what it's going to ask. Is just two pairs of corresponding sides enough information? And we're going to investigate that with doing a little sketching and looking at this idea that Robel has. And so it's saying Robel has a triangle with 4 and 5, and we want another triangle that has proportional sides to 4 and 5 and just no other third side. Is that going to be a condition? Is that always going to create similar triangles? And so in my brain, I'm trying to think of a counterexample to say, no, we can do this and it's not going to work. So I'm going to start by drawing Robel's triangle. This is going to be 4, this is going to be 5, and then we have this side that we don't know. And so we're going to say that this is 4, this is 5, and then I'm thinking to myself, is there a way I can do another triangle that's proportional to 4, proportional to 5, that's going to have to be similar to this? Or is it possible that I can create one that's not going to be similar to this? And so what I'm going to do in this one is I'm going to make a side length of maybe 8 here. Maybe that side length's 8. Maybe this side length here is, maybe this is 10 down here. Or even if I do 10 here. And I have that. So this is 8. Oops, I need to go back to my writing tool. So this here is 8, this is 10. All right, now these two sides are proportional, but this third side we do not know, and it could even be worse than this, and it could, we just do not know enough information here to validate that this is going to be some kind of thing where we can have, there's infinite different ways that this could really play out for us, and so there's no way to really show that just two sides is going to be enough for us, that the side-side similarity, there's so many different ways I can draw this triangle with just knowing two sides that it's just not enough information. And so trying to draw it out and trying to think to myself, how can I explain it here that I know this isn't going to work? Moving forward, there is another one we want to test, and we want to test angle-side angle, ASA, meaning that we start with two pairs of congruent angles and lengths connecting them are proportional. And so if I draw another triangle and one that's somewhat similar to it, we'll draw it a little bit bigger. Okay, with this angle-angle side similarity would be like an angle and an angle here. The angles down here are the same, and then this side is proportional, so maybe this is 4 and this is 8. Okay, that would be like this example of angle-side angle. And we're trying to say, is this enough information to say that these are always going to be similar? Now think about what I have here. I have A and A, okay? And we should know from here that if you have two angles, that's probably going to be enough. And so do we even really need the side? All right, so then we have a sketched image and you can make an explanation here. Okay, now this part here, we want to list all the other conditions that are maybe possible. And so just to get you started on one like this, another one that could be possible is you could have side, 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 angle, angle, angle. You could have side, side, angle. You could have angle, 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 side. There's a lot of different options here, and I want you to try to list all of them, because at the end of the lesson, we're going to come back and cancel out the ones that would work or would not work or that have just too much information. Okay, here we saw that in the beginning that side-side similarity did not work, but now we're going to try side-side-side similarity. Okay, and so we're going to, before we start experimenting on the next slide, I want you to make a prediction if you think that's going to work. So side, side, side compared to side, side. All right, then like we did before in lesson 3.2.2, I believe, or 3.2.1, we had to investigate using eTools, and that's what you're going to do here. You're going to click into these eTools, and then you're going to try to practice these transformations to get one to land on top of the other. And so on this one here, maybe I start by reflecting, and then I translate over, and then I rotate and dilate and see if I can get them to land on top of each other with side, side, side. Okay, and you try it again with triangle, you try it again with the first one and the second one, and then after experimenting we're going to come to a conclusion on if side, side, side was working or not working. Then we're going to talk about if we know that the three sides of a triangle are always congruent. Here we have another one with side-side angle. Is that one going to work for us? And then finally, we're going to go through that list we created, like I said, in slide 4, and delete invalid ones or ones that have unnecessary information. And then we're going to end with just hopefully a list of ones that work for us. Lastly, we have a learning log. And again, if you have questions throughout the lesson, as always, reach out and email me. And remember that we do have synchronous sessions during your class hours on the days you're virtual. So if you're virtual and you want extra help, join those synchronous sessions, type questions into the chat, and we'll address them in class. Or I'll address it to the Google Meeting. All right?